Thanks very much, Gary, for the invitation to speak here this morning. And thank you to Roger Faulkner for his speech last night, not least drawing attention to my little-known and sadistic interest in arachnids, quite possibly also fictitious. But thank you more broadly to Roger for putting flooding, which is what we're here today to talk about, in a very broad global context. In a sense, that provides license for what I'm going to do this morning. Those of you who know my work will know that I've worked on probabilistic methods, reliability analysis of flood defenses, uncertainty analysis. You might be relieved to hear that I'm not going to talk about any of those things this morning. And I am going to take Roger's lead and look at the big picture of flooding and indeed water security more broadly in the global context, and then zoom down a bit to look at the situation in the UK and some recent work looking at changing flood risk and flood defence investment in the UK. So that's the overview of what I'm going to do. And it will all be cast in the context of water security, which is a term which has received a great deal of attention over the last decade or so, and is subject to a number of different definitions or interpretations. But the way in which my team in Oxford have been thinking about water security is very much from a risk-based perspective, that water security is to do with management of water-related risks. And in fact, we're water secure if water-related risks are tolerable to us. On the whole, we're concerned about water because we're concerned about risk. We're concerned when we have too much, too little, it's not of the right quality. And so water security is a process of understanding and managing those risks in a range of different contexts. And those risks seem to be going up the global agenda. In fact, so far up the global agenda that they've gone off this picture. But if you look up on the impact scale, you'll see water right the way up at the top and most of the way over on the right. So it's in this study done by the World Economic Forum, and you might question the methodology around this study. This is based on asking a large number of business executives what they think about the world. But if you ask them, they think that the potential impacts of water crises, is exactly the word they use, are on the same scale or larger than risks, for example, associated with unemployment, underemployment, cyber attacks, asset bubbles, social instability, which I think, it kind of provides a convenient pretext for those of us, all the people in this room who are interested in water and trying to justify that interest. But I think it also raises some very interesting questions as to why it is that this self-selecting group of self-important people who make up the World Economic Forum are concerned so much about water. And in the following, I will try and unpack and provide some new analysis and some results which might to some extent explain that, but also not necessarily on the scale of some of the other things that are on this picture. The main part of this comes from a study that a team I've just led has just completed for the Global Water Partnership and the OECD, a team led out of Oxford involving the World Bank, a number of research institutes and universities from around the world. And the piece of work really was intended to understand why water security is important and why it's important in particular in relation to sustainable economic growth. Because growth is what is preoccupying governments around the world and has been ever since the global financial crisis. So if we're to get water properly on the agenda, we somehow need to understand it in the context of that growth agenda. And so the first question is, as I've already asked, why is it we're concerned about water? And there are many different versions of this, but this is the simple answer. And it's an answer which I think most people, even finance ministers, might be able to understand and even remember. That there are four things that concern us about water. Floods, which is what we're here for at... actually, this is in no particular order. I was going to say at the top, but we'll get the numbers in a moment and you'll understand what the scale is. Droughts and water scarcity, harmful impacts upon the environment, and inadequate supply and sanitation. So just to skip through those, working in particular with the group at IVM, who now in the Netherlands, who now have the best global flood risk analysis model that I know of for fluvial flooding, and Jochen Hinkel and Robert Nichols, who have worked for many years on coastal flood modeling, again at a global scale. We did new analysis bringing together coastal and fluvial flood risks and estimated those risks at the moment to be about $120 billion of property damage per year on average. And, oh good, you can see most of that. We were then able to disaggregate that at national scales, both in terms of risk to people and economic risks. And there are some quite striking patterns here. So flood risk to people are predominantly located in Asia. The pie charts here are divided between fluvial green and coastal blue flooding. The lower panel is the economic risks of flooding. So when you start looking at economic impacts, the USA actually is the place with the largest economic risk of flooding, but you still see, following up on that very closely, huge economic risk to flooding in China, as you would imagine, but also in Vietnam, where the flood risk is just a bit less than 10% of GDP, in India, in Bangladesh. And looking forwards, looking at projections both of socioeconomic change and climate change, that picture in Asia in particular is very striking, in particular in relation to coastal flooding. So the coastal flood risk increases by a factor of 3 or 4 in Asia looking into the future. Looking at droughts and water scarcity, the main impact on a global scale, which registers in economic terms, is in terms of impacts on agricultural production. And if you put this through an agricultural model, which we did with IFPRI, the Institute for Food Policy Research in Washington, D.C., we're looking at the effects of hydrological variability amounting to a loss of about $94 billion per year. And if you look at that, some of those impacts econometrically, so you do the statistical analysis of the relationship between hydrological variability and growth, you find that in places that are water stressed and low income, and have a high agricultural proportion of GDP, so greater than about 20%, their GDP is statistically significantly associated with hydrological variability. So their hydrology is having a direct impact upon their growth. As I say, that main impact is through agriculture, and those agricultural impacts then flow through into malnutrition, which is what we're plotting here, again with the IFPRI analysis, the percentage of the child population that are malnourished. And that malnourishment comes in part because of the variability of agricultural production, which comes from the variability in hydrology. The other aspect that we were interested in was looking at the effect of variable hydrology on cooling water for thermoelectric power plants. So we did a water balance analysis using the relatively new global data set on large dams and the probability of those large hydroelectric dams going below 20% of storage and the effect that that would have on power plant production. And one can see some hotspots, again, in particular in Asia and specifically in northern China and Pakistan, of vulnerability to cooling water shortages, but also in the southern USA, in Australia, in parts of Africa. Inadequate water supply and sanitation is the largest economic impact, about $260 billion of loss per year. These are numbers from the World Health Organization. And when we plot these out, so these are now plotting out deaths from inadequate supply and sanitation. The size of the bubble is deaths in thousands. The color is as a percentage per 1,000 people. One sees Asia and Africa as standing out in that respect, and some real hotspots of inadequate supply and sanitation in Africa. So for the first time, we've put all of those things together. So try to understand as a whole what the economic impacts of water security are, looking at water scarcity in the brown, floods in the beige, and supply and sanitation in the green. And you see that, first let's look at Asia. Asia is subject to all of these main water security risks, an increasing risk of flooding. If you look at Africa, is the only place in the world where risks of inadequate supply and sanitation are increasing, and African agriculture is very susceptible to hydrological variability. Europe and North America have relatively benign hydrological endowments and have invested heavily in water security, but that then implies a commitment to ongoing investment to maintain that security and to cope with increasing flood risks in future. And the analysis showed that South America is particularly vulnerable to hydrological variability. We're seeing this in Brazil at the moment with the effect of droughts on hydropower production and the effects on agricultural production. What's happening to all of that through time? I mean, these are rather impressionistic graphs, but the main story is that the risks of supply and sanitation are steadily going down. They're going down all over the world apart from in Africa. And projections show that that will continue, whereas the risks of flooding, both from rivers and the coasts, is going up and seems in some respects to be going up exponentially. The risks of droughts and water scarcity are also going up, but on less of a scale. And ecosystem degradation, pollution, is a more mixed picture because In some places, like in Asia, those risks are rapidly increasing at the moment, but in other rapidly industrializing countries, they're now beginning to get a grip on their pollution issues. So what the work then went on to do was to try and understand what the interrelationship between these water-related risks and growth are. And this picture tries to depict that. In the middle, there's growth, wealth, well-being. On the left, we have the water endowment. So this is the variability of surface and groundwater sources. If you follow the red lines downwards, that variability leads to risks, and those risks impact negatively upon growth, wealth, and well-being. If you look on the right-hand side, we recognize that investments in infrastructure, institutions, information can help to reduce risks, and they can help to access, in the upper part of the picture, water-related opportunities, which can have a beneficial effect on growth and well-being. But growth itself, which is what the small downward arrow points to, actually increases vulnerability. So as well as providing the resources for investment, it increases the assets which are exposed. And so if we look at this kind of picture, I mean, this is a remarkable figure from the World Bank in Ethiopia, which shows GDP growth is the line, rainfall variation is the grey shading, and this remarkable correlation between the two because of the effect of high hydrological variability. And we developed a model of that whereby those hydrological shocks take money out of the economy, whereas investments reduce the impact of those shocks and so reduce risk. And you can build up a simple dynamical systems model of that and then plot it on this phase space over here, which takes a little bit of explaining, but it's worth trying to get your head round. That along the bottom is the, let's call it the inherent water security of a place. So this is the scale of the water-related challenge that it faces. And on the vertical axis is a metric of wealth. And in there are a number of different regimes of behavior within this phase space. The more commonplace regime is in the kind of top part of the picture where wealth becomes eroded by low water security, and so wealth goes down, and then there is sufficient investment for that wealth to pick up again, and there's investment in water security to safeguard against the water-related risks, and then wealth picks up. There are some fortunate countries over here which are already relatively water secure, and they just simply go on an upward growth trajectory. What we're concerned about are these areas of the phase space down here, where because of the scale of recurrent water-related losses, countries become trapped in a poverty trap of loss where they're unable to recover from sequences of economic impacts from water insecurity. They're not able to make their investments to protect themselves from those losses. An interpretation of this diagram has enabled us to come up with some recommendations as to how and when you should invest at different points in a country's economic trajectory. So what should we do about it? And this kind of points to the same idea. And the first is, how do we decouple economies from hydrological variability? Because you've seen which countries are most impacted by water insecurity. The countries that aren't have somehow decoupled their economies from those water-related constraints. In any case, exposure to extreme floods will increase with growth, so one needs to be preparing for those events. Water supply and sanitation, as we've seen, is an improving picture, but the issue there is that often the benefits don't accrue immediately. One has to complete the system. Some small amount of pathogen in one system can impact a large proportion of the population. So you have to keep going with it in order to get the full benefits of those investments. When making those interventions in the aquatic environment, it makes a lot of sense to avoid degrading that environment, not least because if you do so, it implies massive cleanup and restoration costs in future. So the recommendation really is the need for a portfolio approach to invest in information. That's what a lot of us in this room do, is data analysis, modeling, provision of information to decision makers in institutions, so the way in which we manage water security, and in infrastructure, which is needed to deal with variability and protect societies and economies. And what the work has also demonstrated is these questions around sequencing, that the benefits of investment in water security accrue non-linearly. We need to think of them in terms of systems, which is something I will come back to in a moment in the context of the UK. Avoid lock-in to unsustainable pathways, and above all, spend wisely. So this points to very rigorous appraisal of investment decisions. I've been talking about investment as being a good thing, but not all investments are beneficial. There's been a lot of wasteful investment in water-related infrastructure around the world, and a lot of that investment has had negative impacts upon the environment and society. So appraisal matters. That might sound like a kind of fairly technocratic prescription, but I think it's an extremely important one. And the good news in this country, I think, is that over the 20 years or so that I've been doing flood risk analyses and decision analysis, the standard of appraisal has improved pretty much unrecognizably. But the other thing to also bring into this is the recognition of co-benefits. And that's things like the blue-green cities concept reflect this, that there are multiple benefits which we might be able to access through water-related investments in cities, in the rural environment as well. So what we then went on to do was to look at pathways of adaptation. So what are those sequence of investments? How have different countries done this in different ways through time? This is a picture from the Murray-Darling Basin, kind of the archetypical instance of sequences of institutions and infrastructure investment. Not necessarily, there are no right answers here, and the Murray-Darling is certainly not a right answer. But it shows how there have been how extreme events have triggered policy responses, how there's been a kind of action and reaction around both infrastructure and institutions going through time. Another very interesting picture in terms of investment through time is this one from World Bank work in Japan, which shows this interplay between water-related hazards and economic growth and investment. So the line with the dots on it there is the number of people killed and missing due to floods. And we can see that going along kind of quite steadily during the early part of the 20th century. The red line shows investment in flood defense infrastructure. And around the 1950s, obviously a time of massive reconstruction and reindustrialization in Japan, there was a massive increase in fatalities from flooding. And that reflected this massive build-up in vulnerability, which had been allowed to take place without a corresponding attention to flood risk management. And that came to a head with Typhoon Iswan, in which practically 6,000 people died. And that then kicked off much more attention to flood risk management and this trajectory of investment, which is the red line, which was very high and very sustained pretty much right through the latter part of the 20th century, until it then began to flatten off once fatalities and economic impacts had reached about 0.1% of GDP. And that's an interesting number. It's a interesting number in this country, where EAD is around £1 billion a year. That's, give or take a bit, 0.1% of GDP. It's a number which reappeared in the IPCC special report on extreme events, where they said that for high-income countries, once again, losses, this is from climate-related impacts, are around 1% of GDP. So this feels like a kind of tolerability threshold with respect to risks from climate-related or natural hazards. You can see this number 1%, 10 times larger in middle-income countries, and that's what we saw in Japan in the middle part of the 20th century, where a rapid industrialization increases vulnerability and you get much bigger losses, which the society and the economy then reacts to. The economic losses are lowest are lower, 0.3% of GDP in the poorest countries, though there's a lot of uncertainty around that, because the vulnerable are just so poor. And so what we've gone on to do in this graph here, which was actually published in Science last year, was looking at this interrelationship between hydrological variability on the x-axis, that's measured in terms of the coefficient of variation of monthly runoff, and investments in water security, which is a normalized vertical axis, which includes investments in infrastructure, a metric of institutional capacity. And the color scale, the colored dots represent GDP classification. And you can see a few of this was done based on a global database of 700 or so large river basins, and you can see a bunch of river basins there. And what we see, first of all, is that the richer countries inherently have less variable hydrology. So the green dots tend to be on the left of the picture. And there's nothing anyone can do about that. This is the hydrological endowment. Poor countries tend to be on the right. What you can do something about is where you are vertically. And on the whole, richer countries have invested more in management of water security. But what we see is if you look right the way over on the left, there are quite a lot of countries which haven't invested all that much. If one looks, for example, at the Danube, but they're reasonably water secure anyway because they benefit from an easy hydrology. Whereas the green countries on the right, 15, the Sacramento, number 10, the Murray-Darling, there have been huge investments in water security in order to cope with that very variable hydrology. Whereas if we look at the red dots, they are subject to the highest hydrological variability, and they have the furthest to go in terms of investment in order to get through to water security. What climate change does is shifts the x-axis here and pushes countries further to the right and puts them in a more challenging position in terms of water security. But what we've also demonstrated is that, as we've seen from some other perspectives, is that adaptation can reduce those impacts of hydrological variability. This is looking at the effects of investment in infrastructure on crop production. And we can see not only does production go up, prices go down, but there's also less volatility in a world in which we're paying more attention to coping with hydrological variability. And that leads through to genuine GDP benefits in Africa, in Asia in particular. There are winners and losers in this because this is a global market in food commodities. And so one farmer's gain is to some extent another farmer's loss. But there are net gains overall around the world. But how do we actually choose what to do? And am I running out of time here, Gary? Yeah, okay. Maybe I'll skip over this because it's nice and you can read the papers on that. And just close off on what this means in the UK. And so this is the Cabinet Office's National Risk Register. In a sense, it has some parallels with the World Economic Forum table I started with. And you might just about be able to see that coastal flooding is up there, but inland flooding is right there in the middle, that drought gets a category 2 in terms of the impact. As in the middle in terms of likelihood. So floods, water security are issues as far as the Cabinet Office is concerned in the UK. And the UK's climate change risk assessment, subsequent work by the adaptation subcommittee, which will report to Parliament for the first time next month on the government's progress in implementing the National Adaptation Programme. Floods are up there as being the most significant climate-related risk to the UK. As we all know, the Environment Agency and its counterparts in the devolved administrations have been thinking very strategically about the way in which that risk will be managed going into the future. And one extremely interesting and important piece of work, which many of you will be aware of, is this study here, the long-term investment scenarios, which looked at different levels of investment in flood risk management for the next 50 years, and appraised and sought to optimize those investments and evaluate what the benefits of the investments might be. So this comes from the start of that LTIS study, and kind of sets the scene in terms of what the scale of exposure to flood risk is. But the kind of punchline of the study is this thing here, which looks at a range of different levels of investment on the x-axis there in discounted net present value terms, cost terms, and then NPV, so benefit minus cost on the y-axis. And what we're looking at here is as you increase the cost, you get increasing benefits, and then you increase the cost further, and the marginal increase in benefits begins to decline, and so the optimum is at the peak of that curve there. And the way in which that has been done, I think, is really quite a remarkable piece of work. In around 3,000 flooding systems in England, when it's projected that a flood defence is to become life expired, a optimal decision is triggered, a range of different investment levels are assessed, and the optimal investment level in terms of benefit and cost is identified, and that flood defence is then implemented, and the model ticks on through to the next year. And this is the first time that an optimization on that kind of scale has been done. The Dutch have done an equivalent version of it, but they've only got 53 dike rings, whereas there are 3,000 in England. And I think it points to some very interesting results. It helped the Environment Agency to make a very good case for investment and for its long-term funding settlement with the Treasury over a 6-year period. The first kind of headline that comes out of this is that the optimal level of investment, around about 860 billion a year, is about 15% more than the current level of investment. That's not as much more as at least I was expecting, given that schemes at the moment have a benefit-cost ratio often of around about 8 to 1. So if things are really that cost beneficial, one might have thought that the optimal level of investment was a bit higher. But this is what the numbers are coming out at, and I, having looked at them carefully, on the whole, trust these numbers. So that's one interesting result. Another very interesting result for those of us concerned about adaptation and climate change is that flood risk in the future is manageable. If we think back to the Foresight study, that had a 20-fold increase in flood risk going into the 2080s. What this is saying here is that one can keep up with climate change, at least through into the 2060s, and you can get the risk down by a bit. Not by very much, and that optimum is also dependent on some really quite ambitious year-on-year cost savings. So the amount you can afford to get risk down by depends on how much cheaper you can make flood defences, which is a good challenge to everyone here. The other kind of interesting thing that comes out of this is that sequencing doesn't really matter all that much. So if we're concerned about, for example, partnership funding, enabling projects to jump the queue, in the end, the precise sequence in which you put in different projects doesn't matter too much to this. And so on the whole, partnership funding is a nice thing if you can get it. And the other interesting observation here is that this is an adaptive system. Often we're concerned about flood defences because we're building big concrete stuff which lasts right the way through until the end of the 21st century. But actually, if you look at it at a macro scale, what we're doing is putting a portfolio of investments into 3,000 different systems. We revisit each of those systems sequentially through time, and we're able to adapt to changing climate information each time we revisit those systems. So looked at a macro scale, actually, this is quite adaptive. The other, and this is the final set of insights, Gary, you'll be pleased to hear. A very interesting thing that came out of this analysis is the way in which the risk profile is projected to change. So the left-hand side is the histogram of the current distribution of properties, and you can just see the top of the legend there. High is 1 is more frequent than 1 in 30. That's the dark blue. The green is medium, 1 in 30 to 1 in 100 return period. The light blue is 1 in 100 to 1 in 200. The green is less frequent than 1 in 200. And what all of this investment gets us to is to the next histogram, the one which is pointed at 1. And that risk reduction comes primarily through medium and low risk properties being shifted into the very low risk category. There's actually a small increase in the number of properties in the high risk category. Now, those aren't all the same properties. Some properties come out, some new ones come in. But there is this kind of stubborn residual of high-risk properties where it's not cost beneficial to invest in community-level defences to get the risk down. A bit of work was then looked at the possibility of property-level protection to protect those properties. Given the current level of uptake, that's not going to make much difference at all. But with a 50% uptake, that gets that residual risk down a bit. There's also a interesting set of questions with everything that's left in that green bar there, which really gets me to the kind of closing challenges that emerge from that analysis. The top one being, can that residual risk, so can those 3,000 or so high-risk properties, how can that risk be managed? Can it be managed through property level protection? To what extent will some of those communities become untenable? What role does flood have in helping to promote adaptation in those communities? Then at the other end of the spectrum, there's a recognition that actually overall exposure is going up. Much of it is in very low risk categories, but we know that flood events with a return period of more than 1 in 200 years does occur. And with that background increase in vulnerability in the low risk category, it means that there will be occasional extremely disruptive floods which will impact infrastructure networks and will have systemic impacts upon the economy and society. And can that systemic risk be managed? And then the final question, which LTIS didn't answer, is because it was based upon basically holding the line within every flood defense system, what communities, either in fluvial settings or in coastal settings, is it inevitable that it will no longer be cost effective to maintain those community level defenses, and so what can be done in that setting? And no one is able to answer that question for me. On the coast, for example, how many kilometers of coastline will it be not cost beneficial to protect going through into the future? And I think that's a very interesting question. And with that, I will close. Thank you, Gary.